So today we are starting our intro into circles. Now, as far as circles go, there's a lot in this section, or a lot in this chapter, I should say, because usually circles are tested a little heavy on the FSA. But this first section is just an intro, bring back some ideas that you guys have talked about in the past, really. So first off, just naming different pieces. There's only really one new word in this entire section for 10.1, and that is the word core. All right. The rest of these, so the word core, that's really the only new word that you probably aren't familiar with. And I say new, but you've probably actually seen it before. It's probably more like you don't remember it because it's not a common word that we use all the time about circles until you get to geometry. So probably seen it, but highly likely that you don't remember it. So the rest of these, circle, radius, diameter, center, those are all things that you should already be familiar with, right? We know what a circle is. This round object over here is a circle, right? Again, we know what that looks like. Now, the definition of a circle is a circle consists of all points in a plane that are a given distance called the radius from a given point called the center. So F is our center of that circle. FC could act as a radius. It's that same distance all the way around. So every single point is equal distant away from the center. Then we have, again, the radius. The actual definition of a radius is the segment with endpoints on the center and on the circle. A chord is a segment where you have both endpoints on the circle. So EA in the diagram is a chord, but also DB or BD, that's also a chord. Now, we also know that BD is a diameter, but a diameter is a type of chord. Diameter is a chord that passes through the center of a circle. Again, that's really the only new word. Other things that you should be familiar with, how does a radius and a diameter relate to each other? A radius can be considered half of the diameter, or the diameter can be double the radius, right? So that's talking about length. Down here, this is just all about naming the different pieces. So name the circle. Well, the point in the middle is O. We name the circle based off that center point. So this is circle O. And it's just a picture of a circle with the letter O next to it. Name the radii. Radii is plural for radius. So if it says name the radii, it's asking for more than one. Now, any one of these segments that come off the center point and go to the side of the circle, those are the radii. So AO, CO, DO, and BO are all radii. Now, all radii in the same circle should be what? They're all going to be congruent. Right? Same thing goes with diameter. If you have more than one diameter in a circle, all the diameters in the same circle would be congruent. All right. For C, name the chords of a circle. So AD, it's a diameter, but it's also a chord. And then CD, those are both chords. A lot of the ideas from way early in the beginning of the year are coming back here as well. Notice when we name them, we're using a segment over top because we're calling them by segments. For example, segment AO, segment BO, segment AD, segment CD. So we are using the correct notation again. Now, down on the bottom, bottom of these exercises, again, they're just naming all these different parts. So they're doing a whole lot here today. Name the circle. Well, what's the center of that circle? R. So this is a circle, R. Name the radii of the circle. All right, the radii there are 4 radii coming off that center point. There's AR, there's XR, there's YR, and there's BR. And again, we label them as segments. So there's a segment AR, segment XR, segment YR, segment BR. We have a segment symbol over top. On number 3, name the chords of the circle. So the chords, there are actually 4 chords there. There's AX, There's YB, which is down there at the bottom. And then there's two more. What are the other two chords? AB and XY, yeah. AB and XY. A lot of times people look at that and forget those two because AB and XY are also what? Diameters. So those two are also the answer to the next question. So AB and XY are diameters as well. And we do have to remember, every diameter is a chord by definition. All right? Now, 67 there, just talking about lengths a little bit. You'll notice it says if AB is 18 millimeters. Now, AB doesn't have a line over top because we're talking about length again. When you talk about length and distance between 2 points, you don't put the bar over top. So the length of AB is 18. So they say that this piece here, oops, sorry, whole thing, AB, is 18. Well, that whole thing is 18. What's R or what's AR? None. It's half of it. So they gave me a diameter and they're asking for the length of the radius. So AR is equal to 9. Now, each one of these is a little bit separate. So the next one, we're now doing RY, and they say it's 10 inches. RY, that was 10 inches. Find AR. Well, first off, if this is 10 inches, AR would also be 10 inches because all the radii must be congruent. So AR equals 10. And AB, which is the entire line, would have to be what? 20. Yeah, double the radius. Diameter has to be double the radius. So AB is 20. And we should probably include units on each of those. Last problem that was in millimeters, this one was inches. Again, each of those are separate. They're using the same diagram, but they were if. They said if at the beginning, so we were using different values on each one. Now, on 7, is AB congruent to XY? Segment AB is congruent to segment XY. Yes, because those two are both diameters, and diameters in the same circle must be the same length. You want to put that whole explanation down, you can, but you understand they're both diameters. Right? All right. On the other page, so now again, like I said, this is a lot of review ideas. You have done circumference before, right? Circumference. When we talk about circumference, there are two formulas for circumference, and they have them written up there at the top. Circumference is equal to pi times diameter, or circumference is equal to 2 pi r. Again, you can switch out the d and the 2r because 2 times the radius is the diameter. Right? Now, what is pi? So I heard say 3.14. So pi, an approximation for it is 3.14. Does anybody know the other approximation for pi as a fraction? What's the fraction approximation? Anybody know? Any guesses? It is 22/7. Again, are either of those actually pi? No, they're just close. They're approximations. They're rounded. All right. Neither one is really pi because pi is what we call an irrational number. It goes on forever, right? Never repeats, never stops. It keeps going. Now, does anybody know what the definition of pi is? How do we define pi? How do we define pi? Yeah, these are approximations. What's the definition? No. So pi, it is a ratio of circumference over diameter. In every circle, the ratio of the circumference of the circle, which is the distance around the circle, same as like the perimeter and polygon, but the circumference is the distance around the circle, and the length of the diameter, you put in a ratio, it would give you 3.14. It's always the same. So that's what pi is. It's the ratio of circumference over diameter. And that's how we're able to have this equation to find circumference. So now, on this part, so they did the equation here, they find the circumference of the circle to the nearest 100. They drew in a radius that says 13, they plugged it into the formula 2 pi r. They did 2 times 13 equals 26. And then they plugged it into the calculator, 26 times pi, and they got 81.68. Now, a couple things to be careful of. Right here, this step, 26 pi, that's an exact value. All right. Just like in the last section, we had exact values when we were using our radicals. Here, if we're doing exact values, this is an exact value. This is what we call in terms of pi. Because when we had a radical in the last section, most of those radicals that can't be simplified, they are also irrational numbers. Pi is an irrational number. It goes on forever, right? So if we were to go past the point of multiplying by whatever that irrational number was, we're going to have to round. An exact value is an answer that's not rounded. So we're leaving it in this format in terms of pi. Just like in the last section, we left it with a simplified radical. Now, some other problems will ask you for exact values. Some will ask you to use the calculator and round your answer. If you use your calculator, normally it will tell you to use one of those approximations for pi, 0.14 or 22/7. On this one, it didn't say. You actually do have a pi button on your calculator that'll give you a closer approximation. So if you hit the pi button on your calculator, it does like the whole pi out to many, many decimals. Now, down here, I want you to try it. All right. So they give you a circumference. So you can plug this into your formula for circumference. We have 40 equals pi times diameter. Well, to get diameter by itself, we would have to divide out pi. So you can plug that into your calculator and do 40 divided by pi, and you'll get an answer. So I do want you to try this. Down here on the bottom, move this up. This is where we're getting this out. Down here on the bottom, notice they don't give you all of your too far. They don't give you the radius of the diameter. You have to find it. But what you'll notice is there's a lot of diagrams that look a lot like what we've already done in the last chapter. Triangles, squares, other things. We have to solve for a missing piece. So solve for a radius or solve for a diameter before plugging into our equation. You've used the equation before, so I want you to try these. So this is page 6 on that worksheet, 1 through 12. Now, if you still have a test or something out, make sure your name's on it so that I can collect it from you. We have, why do they release so early out there? There's like 2 minutes left. Now it's 1 minute, but when all those people left. All right. If you have a test or something for me to take.
I'll give more time to finish it tomorrow.
Yeah, you need more time? I can do that. You need more time? You need more time? Or you good? You do? Okay.
I won't be here on Thursday though. I have to go to some of the.
So you have to do it Friday?
Yeah.
All right. You need more time? No? Anybody else? Did you need more time? Thank you. Thank you. Oh, man. Done today. Whew.